Well, we've all heard the term polar vortex, right? When we get really cold for a time in the wintertime, but what exactly is the polar vortex? And some of this might surprise you. Let me show you what's going on here. So the polar vortex is this big swirl of air, if you will, swirling counterclockwise in the Arctic, and it's over the poles. Typically, again, it's a loft over the poles, really frigid air in the Arctic. Now, I want to mention here, this is nothing new, even though a lot of folks didn't hear of the polar vortex until maybe 2012, 2013, 2014, as it kind of became a buzzword back then, and now you hear the term polar vortex and you think, oh, it's going to get really cold. Let me emphasize here, the polar vortex is nothing new, number one, and number two, it's always there. The question is, when does the polar vortex break off and send some of that Arctic air down our way? Well, when you have a strong jet stream in place, it keeps that colder air up towards the Arctic. There's a large pressure difference in association with that jet stream, and it kind of keeps the colder air locked up in the Arctic. But when that jet stream starts to weaken, it can allow that colder air to spill south. This is when we get those kinks in the jet stream, those troughs, if you will, troughs of low pressure in the jet stream, and that allows that colder air to spill south, which is sometimes what we see in the wintertime, and this is what causes our air temperatures to drop below zero and also causes our dew point to drop below zero, so very cold and very dry Arctic air that spills in. But again, it's important to mention this is nothing new. This is not new terminology. It's just more people are hearing about it now when we get especially cold for a time in the winter months. Now, from a meteorological standpoint, we look at a couple of different things when it comes to trying to diagnose the polar vortex. We often talk about El Nino and La Nina, right? And that can play a role in shifting the jet stream, for one. But we also look at something that's called the Arctic oscillation. And when that is in its positive phase, that Arctic oscillation, it keeps the cold air up into the Arctic. Well, when it's in the negative phase, it can cause, that means that there's a kink in the jet stream, and it can cause that cold air to start spilling south. So again, there's some different ways that we can diagnose if it's coming or not, but again, it's nothing new. It's always up there, even in the summertime. It is up there in the Arctic. The question then becomes, do we see a weather pattern conducive to allow that frigid air mass, that Arctic air mass, to spill south? And again, I mentioned before, it's a loft, right? It's above us. We often look at about 5,000 feet for temperatures like this, but it can affect us, of course, here at the surface as well. Why is that? Because cold air is dense, right? Cold air is denser than warm air. How do you know it? Have you ever stood barefoot in front of your freezer before and that cold air just came spilling down to your feet? There you go. You created your own cold front at home when you do that. And again, that's that cold air with the polar vortex that can spill south into our area a couple of times a winter if conditions are just right.